Hi guys, welcome to my YouTube channel, and in this video we are going to discuss types of organic reactions and reaction mechanisms. So reaction mechanisms are very useful, and chemists normally summarize the types of organic reaction in a series of steps that are called reaction mechanisms. So they are of two types. One is homolytic fission and heterolytic fission. In homolytic fission, in this type of bond breaking, so there are type of bond breaking, and also we're going to look at types of bond formation. So in this type of fission, both atoms at the end of the bond leave with only one electron. So both of the atoms that are forming a bond, that is a covalent bond for that matter, each of the atom leaves with one electron that was forming the bond. For example, in hydrogen chloride, that is shown here, when the bond is breaking, one electron leaves with hydrogen and the other one leaves with chlorine. So this type of a reaction is known as homolytic fission. So we are going later on to discuss how such kind of reaction takes place through the formation of radicals, through the initiation steps, whereby we have the reactants initiating the reaction, and then we have propagation or chain propagation steps, and then lastly termination steps. We are going to discuss that in later on videos. Then the second type of reaction is known as heterolytic fission. It's a type of bond breaking in which two of the elements that are forming this bond, the two of the electrons are taken away by one of the electrons, one of the atom forming the bond. So for example, hydrogen chloride can also break the bond between hydrogen and chlorine, can also break heterolytically, whereby the electrons forming the covalent bond are both of them carried away by the chlorine molecule. So this type of bond breaking can be shown in an equation as displayed, where you have hydrogen and chloride bond, and then that bond breaks, whereby the hydrogen is left positive and chlorine is left negative with both of the electrons forming the bond. Then we can also have bond breaking when you represented in C and X. For example, when you have methyl bromide, for example, so both electrons forming the bond between the methyl group and the bromine are carried away by bromine. So in that case, that's also a heterolytic type of fission. So in this bond breaking, the bromide takes both of the electrons that are forming the bond, forming an anion, which is a negatively charged ion, and that one leaves the carbon. It leaves the methyl group with one electron short. Now it's said to be electron deficient, and therefore it forms a positively charged ion, which is called a carbocation. So the positively charged ions, they can be of three types, depending on how many molecules are joined together with the positively charged carbon atom. So it can be primary carbocation, it can be secondary carbocation, or it can also be a tertiary carbocation. So if it can be a primary carbocation if it is only joined to one R group, it can be secondary carbocation if it's joined to two R group, and it can also be a tertiary carbocation if it has three R group linking directly with the carbon atom. So the primary carbocation is the least stable carbocation, while the secondary carbocation is a bit stable, and the tertiary carbocation is the most stable carbocation. So the carbon atom with the positive charge has 3 covalent bonds and not the 4 covalent bond because one of the electrons forming the bond was taken away. So the carbon that is bonded to most electron donating group, that is the methyl group. The alkyl groups, maybe the more the alkyl group that are bonded to that are joined to the carbon atom, the more stable the carbocation is, and that is where you find the tertiary carbocation is the most stable type of carbocation. So the arrows in those figures that are displayed there, they represent the inductive effect on that carbon atom. The alkyl group, they normally push electrons away from themselves. The R groups, they push electrons away from themselves, and therefore reduces the charge density of the positively charged carbocation. So that normally affects the spreading out of charge around the carbocation, making it more energetically stable. So the more electron donating group are there in the carbocation, or in bonding the carbon that's around the bonding that carbon, the more the alkyl group, the more the inductive effect, and therefore the more stable that carbon group is. So generally, the more alkyl groups that are next to the positively charged carbon atom, the more stable the carbocation is. So that is why the tertiary carbocation are most stable, and they are likely to form in most reaction mechanism than the secondary carbocation and even the primary carbocation. So carbocation, they are examples of a species that are known as electrophiles, the electron donating groups. So later on we are going to discuss about the nucleophiles, yes, in later videos. So there are some questions there that you write an equation to show homolytic fission between chloride-chloride bond in a chlorine molecule. So for homolytic fission, you have bond breaking where one electron will leave with chlorine and the other one will leave with the other chlorine. So write an equation to show the heterolytic fission between a carbon chloride bond in chloromethane and include a carry arrow in your answer. So for heterolytic fission, we said that both of the electrons that are forming the bond are carried away by one of the atom. So the chlorine will leave with both electrons, and then the carbon will be left as positively charged. So then you are asked to which of the following species is likely to act as an electrophile and which one is likely to act as a nucleophile. So for electrophiles, they are the electron donating groups, and the nucleophiles are electron deficient groups. So then you are told which of the carbon is likely to be the most to form the likely to form an intermediate in an organic reaction. You have B, which is the tertiary carbocation, and then you have C, which is a primary carbocation, and you have A, which is a secondary carbocation. So the one that is likely to form an intermediate is a primary is B, which is a tertiary carbocation. So then we are going to discuss the types of organic reactions. So there are of different types, and later on we are going to discuss the mechanism involved in each and every type of reaction. So the first type of reaction is addition reaction, and that one involves the formation of a single product from two or more reactant molecules. For example, if you have ethene C2H4, you add bromine, you're going to form bromoethene. Elimination reactions, these ones, they result in removal of a molecule from a larger, you remove a portion, a small molecule from a larger reactant molecule. For example, using a dehydrating agent. So when you use conc sulfuric acid to dehydrate an alcohol, then in that case you are doing an elimination reaction. So for example, ethanol, you react with concentrated sulfuric acid to get ethene plus water. Now you are eliminating a small portion of water from that molecule. Condensation reaction, they now involve, first step is addition, then elimination reaction. So those condensation reaction, you first add, then you eliminate. Then substitution reaction, they involve replacement of one atom or a group of atoms by another. For example, in the free radical substitution reaction, where you add a chloride group or a bromide group in an alkane. So you have a methane, for example, you add chlorine in presence of UV, right? You are going to get chloromethane plus hydrogen chloride. In this case, from the methyl group, you have removed a hydrogen and then it has been replaced with a chlorine, and that is why you get CH3Cl instead of CH4. So you've substituted a hydrogen group with a chloride group. So then we have a hydrolysis reaction, where it involves breakdown of a molecule by water. So you can also add an acid to help in hydrolysis, or even you can also add an alkali. For example, if you have bromoethane, you react with water, you are going to get ethanol plus hydrogen bromide. But then if you use an alkali for the same purpose, hydrolysis, you're going to get ethanol plus sodium bromide. So the products are different, and depending on the reactant agent that you use. Then you have oxidation reaction, which is the loss of electrons from a species. So in oxidation reactions in organic chemistry, we use oxidizing agent, for example, potassium dichromate solution, and in this case you represent using an oxygen enclosed in a box bracket. For example, if you have ethanol, you oxidize it, you are going to get an aldehyde, which is ethanol plus water. So but make sure you balance the oxygen atoms in both sides to make sure they are the same. So O in box bracket represents the oxidizing agent. So then reduction, that's when you use reducing agents. You can use you represent a reducing agent with a capital H. So for example, you can use tetrahydroborate NaBH4 to reduce a substance, and therefore again you make sure that you balance the hydrogen atoms on both sides of the equation. So the others are questions that you're going to tackle in the next lesson. Don't forget to subscribe to my channel to watch more as we discuss the organic chemistry. Bye.